Now let's talk about coterminal angles. And two angles are coterminal if they are in standard position and if their terminal sides overlap. So, for example, if I had an angle in standard position, meaning it starts on the positive x-axis and it swings open, let's say it swings open to this position. That's the first angle. Now let's say I do a second angle, I'll do it in blue. Let's say I have a second angle that starts in standard position, but I do a full rotation and then open up again so the terminal sides of both angles land in the same spot, so they're overlapping. So even though they're two different angles, their terminal sides lie on top of each other. And that's why these are called coterminal angles. Co means together. Okay, so in example A, we're going to check to see if the two pairs of angles are coterminal. Now, there are two ways that you can do this. You can actually draw the angles and see if the terminal sides overlap when they're in standard position, or you can subtract and find the difference between the two, and if the difference between the two is a multiple of a full rotation, then they're going to be coterminal. So for the first pair, you want to take, if you're going to just check it by subtraction, you want to take the bigger angle and minus the smaller angle, and look to see if that is a multiple, since this is in degrees, a multiple of 360. So multiples of 360 would be 360, 720, and then if I add another 360, that would be 1080. You want to just see if it's some kind of multiple of 360. So if I take the bigger angle, which is 330, and I subtract a negative 30 degrees, that's going to give me a positive 360 degrees. So that is definitely a multiple of 360. So these are coterminal. So if you check by drawing the angles, negative 30, I'm going to draw in red. And if I draw this in standard form, I'm going to have my vertex at the origin. My initial side is going to start on the positive x-axis. And because it's negative 30, I'm going to swing open clockwise. So I'm going to swing open in this direction 30 degrees. So this would be negative 30 degrees when I swing open this way. Now, I'm going to draw a positive 330 in blue so that we can see the difference. I'm going to draw positive 330 in standard form as well. So my vertex is going to be at the origin. My initial side is going to be on the positive x-axis. Because it's positive, I'm going to swing open in the counterclockwise position. And as you know, a full rotation is 360. So if I swing open 330 degrees, it's going to be 30 degrees short of a full rotation. So I'm going to swing open 30 degrees short of a full rotation would land right here. So their terminal sides overlap. Since their terminal sides overlap, then that's the other way that you can look to see if they're coterminal. Or by finding the difference between the two, and since it's in degrees, you're looking to see if the difference between the two is a multiple of 360 degrees, which would be a full rotation. Now, for the second pair, let's do it in this box. These are in radians. So when I take the difference of these two, I want to look to see if it's a multiple of 2 pi. Since 2 pi is a full rotation in radians, I'm looking to see if this is a multiple of 2 pi, meaning 2 pi, 4 pi, 8 pi, etc. So when I take the difference between 32 pi over 3 and 11 pi over 3, if it's not 2 pi or 4 pi or 8 pi, it's not some difference where it's a multiple of 2 pi, then they're not coterminal. So I'm going to take the bigger of the two and subtract the smaller. So I have 32 pi over 3 minus 11 pi over 3. My denominators are the same, so I don't have to come up with a common denominator. So I take 32 minus 11, and it's 21 pi over 3. So 21 pi over 3, if I reduce that, would be 7 pi. So this is not a multiple of 2 pi, so these are not coterminal. In example B, it says find an angle that is coterminal with negative 100. Now, there are so many different angles that are coterminal with negative 100, and we just need to find one of them. So remember that two angles are coterminal if their terminal sides overlap. So maybe they swing open a different number of rotations, or they swing open in a different direction, but they're still going to land in the same spot. So if I just take negative 100 and I add 360, that's going to give me a positive 260 degrees, and that's going to give me a coterminal angle. And I can check it if I do a quick drawing. Remember, if I open up to the positive y-axis, that's 90 degrees. If I open up to the negative x-axis, that's 180 degrees. If I open up to the negative y-axis, that's 270. And then if I rotate all the way around and make a full rotation, that would be 360 degrees. So if I want to go to negative 100, if I draw that, I draw it in standard position. So I would have to start on the positive x-axis, and because it's negative 100, I would have to open up clockwise. So that would be in here, because if I open up a quarter of the way, that's 90 degrees. So from here to here is negative 90, and then I have to go another negative 10 degrees to make a full negative 100. Now, if I open up positive 260, which this is what I'm claiming is our coterminal angle, if I open up, if I start on the positive x-axis and I open up 260 degrees, that's going to be 10 degrees short of 270. So that's going to be right here. So you can always draw and check to make sure that we did it right. Now, I could come up with another coterminal angle by adding another 360 degrees. And I could keep adding multiples of 360 to get more coterminal angles. But the question only asks for one, so I'm just going to say the answer is 260 for this one. Now, I could say find me a coterminal angle that's between 360 and 720. In that case, I would have to add another 360 to get between those two angles. But the directions don't specify to find an angle between two values, so I can just come up with any coterminal angle. Now, in part C, we're given an angle in radians, and I can tell that it's in radians because there's no degree symbol. So I know that this is in radians, so a full rotation would be 2 pi. So if I want to find a coterminal angle with 51 pi over 2, I would add or subtract 2 pi. So if I add 2 pi, I would have to find a common denominator. So I would multiply the top and the bottom of 2 pi over 1 by 2. That would give me 4 pi over 2. And now I can add them. So I would get 55 pi over 2. So that is one of the many coterminal angles we would have with 51 pi over 2. I could also subtract 2 pi. As long as you're adding or subtracting multiples of full rotation, you're going to get coterminal angles.